हेलो माय डियर मैकेनिकल एंड सिविल फ्रेंड्स, हाउ आर यू ऑल? व्हाट्स अप? कैसे हैं सब लोग? प्लीज गाइस डू जॉइन मी फास्ट so that we can start our session on time. This is Chandrasekhar once again welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. So first of all, do let me know if I'm audible and visible to you all perfectly. Can you guys hear me? Those who are physically, mentally, and emotionally present to the session, please do write in the comment section. Ranveer is always on time. Good, Ranveer. I also need to learn from you. Be on time, being on time. So, am I audible and visible to everyone? So, as you can see over the screen today, we will be going to enter into the next level of our fluid mechanics, that is the understanding of the fluid dynamics. What is fluid dynamics? Anybody is having any idea? So today we will be talking all about the concept of ideal flow. Hi Pawan, welcome, good evening. Kintu, welcome guys, welcome once again. I would like to welcome you all from the bottom of my heart to the beautiful subject as well as the beautiful session on BYJU'S YouTube channel, which is going to be benefited for all the mechanical and civil aspirants who are going to appear for GATE 2023. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Wanakam. I hope I am audible and visible to you all perfectly. So you guys are watching me live through the series which is going to be important for 2023 aspirants. Here in this free series, we are providing you the conceptual clarity of all the subjects as well as the practice sessions are also conducted. So this is how you will be getting benefit out of these sessions. So I would like you to share this session to all your friends who are mechanical and civil engineers who are preparing for targeting for GATE examination. This is my entire schedule, though my my schedule is about to end. Yes, definitely, Pawan. There are classes running on BYJU'S app also. There are parallelly classes running on the YouTube channel also. So you can join app as well as YouTube channel, and we are having the paid courses also running on BYJU'S platform. So in every possible way, we are trying our level best to be part of your success journey, either by providing you the free content on YouTube or app, or being part of your journey by giving you the guidance through the paid courses. All right, so this is my schedule, entire schedule. Every alternate day at 8 p.m. the classes are going to be conducted, and day after tomorrow be there for mentee session, live quiz, which will give you the clear understanding of all the topics which we have covered so far, whether you are comfortable in the application of those concepts or not. All right, the syllabus of the mentee quiz will be these topics only, which I have discussed in the class. All right. So what we are going to discuss today, let me have the brief idea about that, then we will proceed further. First of all, we will talk about the Euler equation. Euler equation is the basis for developing the Bernoulli equation. The very well-known equation is Bernoulli equation, which we frequently use in our analysis of fluid dynamics or analysis of ideal flow. But the basis of developing the Bernoulli equation is Euler equation. Then we will be talking about the various assumptions in which the Bernoulli equation is going to be valid. Because without understanding the assumptions, you will not be able to find out just whether to apply the Bernoulli equation or not. After the assumptions, we will also talk about the energy conservation equation applied for ideal flow as well as real flow. Both types of flow. And lastly, but not the least, we will be having some numerical practice also. Hi Devabrat, good evening, welcome. Ranbir, I have no idea about the BARC result. How was your exam? Are you Are you getting selected? Are you hoping for getting the uh, positive result? So keep on watching their website. Definitely all the information, all the reliable information will be there on their website. All right. So can I just uh, ask you, what is ideal flow? What is ideal flow? Are the ideal flow or real flow, are the ideal flow or ideal fluid same? What is the difference between ideal flow and ideal fluid? Can you just let me know what is the difference between ideal fluid and ideal flow? Are they same or are they different? So as always, I bring you a very simple or basic question. Before we start our session, there is a question on the screen. I want you to let me know the answer, true or false. The statement is Bernoulli equation can be applied between any 2 points on a streamline for rotational flow field also. Is the statement correct or not? Is the statement correct or not? I will let you know what is ideal fluid, what is ideal flow. Stay with me till the end of the session. I will resolve all your queries. But there is a question on the screen. Please do let me know whether the statement is true or false. Before I proceed further, this is my quick introduction. I am a mechanical engineering graduate from IIT Delhi and also an engineering services examination qualified, having more than 9+ years of teaching and having more than 4 years of industry experience as well. And I am quite comfortable in these subjects of mechanical engineering which are mentioned over the screen. And you can always join me on the Telegram group, or you can always contact me through my mail ID which is there on the screen. You will get all the, once you become part of my Telegram group, you get all the notifications, exam notifications. You will be provided with the PDFs and notes and session updates. And I have brought the daily important questions and doubt clarification session as well. My Telegram group is Mechanical by Chandra Sir, and the link is also mentioned over the screen. All right. Yes. Ranbir and Setupati are saying false. Anybody here who is thinking the statement is true? To your surprise, guys, the statement is correct. It is not false. The statement is true. Yes, we can apply the Bernoulli equation for rotational flow field also. The only condition is the points for which we are applying the Bernoulli equation must lie on the same streamline. Do you get it? When the flow field is irrotational, any 2 points can have the Bernoulli equation to be applied. But if the flow field is rotational, then the point must lie on the same streamline. Then we can still apply the Bernoulli equation. I hope it is clear. So the statement is not false. The statement is actually true, to your surprise. And as I mentioned, we are running the paid courses also. You can be part of our paid courses. We have produced all India ranks in single digit as well. In the previous GATE examination, we have proved ourselves with our results. And there is an important announcement before we proceed further. If you want to be part of our paid course, BYJU'S Exam Prep is conducting the scholarship test on 1st of May. And based on your performance in the scholarship test, you will be able to avail up to 90% scholarship on our paid courses. So that is very, very good opportunity. Those who want to be part of our paid course, so you can have the discount based on your performance in the, so you will be getting two advantages. One is you will understand your preparation level, and at the same time, based on your preparation, based on your performance, you will be able to avail the scholarship also. So share this information to everyone. The timing will be 11 AM and the syllabus will be GATE syllabus. All right, so shall we start? So it is my humble request to all of you, those who are part of this session, to like this session so it reaches to maximum audience, and share this session to all your loved ones, all your friends, and do not forget to subscribe our BYJU'S YouTube channel. That gives us the motivation to bring the content in the most simple, most interesting manner. All right. Okay, so without wasting much of your time, let us start. Are you all ready? Please make some noise. Are you all ready? Have you liked the session? Have you shared the session? Have you subscribed the channel? Then only I will think that you are already charged up to explore this session. All right, good, good. Hi, Fantasy Karnataka. Welcome to the session. Okay, so first of all, we will discuss the assignment question. Very simple question, but the question was from acceleration study. Incompressible flow field is given by U and V. What is the answer to this question? V is minus 4xy. The convective acceleration. What is the local acceleration if the flow is steady? Do you agree? Local acceleration will be 0. The convective acceleration along x direction. So the x formula for ax convective is equal to u into del u by del x plus v into del u by del y. Will give you the result, and the point where we need to find out the acceleration is 1, 2. Do I need to solve it, or you will be able to solve it on your own? U is 2x square plus y square. Then del u by del x is 4x plus v is minus 4xy into del u by del y is 2y. Put the value x is equal to 1 and y is equal to 2. You will get ax convective as minus 8 units, isn't it? You will be getting minus 8 units. Can you find out ay convective? Had anybody tried ay convective? Can you guys find out ay convective? If you want to find out ay, local will be 0 because the velocity is not a function of time. The flow is steady, so the local will be 0. So for ay convective, you need to write u into del v by del x plus v into del v by del y and put x is equal to 1 and y is equal to 2. Can you let me know whoever had calculated ay convective? And if the question is asking you to find out the total acceleration, then it is under root of ax square plus ay square, isn't it? What is ay? What is the value of ay? I have also given it a try. I had also tried it. I had got minus 16 units. Did you guys got the minus 16 units? So it is 8 square plus 16 square under root will be the total acceleration at 1, 2. How many of you have got minus 16 units? This was one of the question. And there was another assignment question for a tapered duct where the area is decreasing with x. As x increases, area will decrease. X is the distance in meter. At a given instant, a discharge of 0.5 meter cube per second is flowing in the duct and is found to increase at the rate of, what is this? This is dq by dt. The rate of change of discharge is 0.3 meter cube per second per second. What is the answer? The local acceleration in meter per second square at x is equal to 0. What is the expression for local acceleration? It is del v by del t, and v can be written from the continuity equation del by del t. V is q by a because area is not a function of time, so it is 1 by a into del q by del t will give you the answer. So that is what is 1 by a? 1 upon 0.5 minus 0.2x into what is del q by del t, that is 0.2, and at x is equal to 0, we will get the local acceleration to be 0.2 upon 0.5, that is 0.4 meter per second square. Yes, Bhavya, well done. Good. C is the correct answer for this as well. Can you find out the convective acceleration? Had anybody tried for convective acceleration at x is equal to 0? What is the value of convective acceleration? What is the value of convective acceleration? If we talk about the convective acceleration, that is v into del v by del x. That is how the convective acceleration will be. क्या आंसर आया भव्या बताइए? जो भी लोगों ने सॉल्व किया है या ट्राई किया है, a person who never make a mistake had never tried anything. That is how it works. The more you commit mistake, the more comfortable you become. Yes, yes Bhavya, I am also getting 0.4. So v is q by a, that is the velocity, into del by del x. We can write q by a. Q is not a function of x, area is a function of x, so it will be q square upon a into del differentiation of 1 by a. That is how it will be solved. So q square by a into del by del x, 1 upon 0.5 minus 0.2x. Can you do the differentiation? Can you do the differentiation? It will be q square by a into, it will be minus 1 upon 0.5 minus 0.2 whole square into minus 0.2. Area is also this. If you will do the calculation and put x is equal to 0, you will get 0.4 unit or 0.4 meter per second square. You will get 0.4. So ax that is correct answer. All right. चलिए आगे बढ़ते हैं. Let us start our session. The session is all about the fluid dynamics, which is the analysis of the moving fluid considering the forces causing the motion. Dynamics is all about the fluid analysis, moving fluid analysis considering the forces. And what are the various forces acting on the moving fluid? One is pressure force. What is the pressure force? Pressure force is pressure into area. Then the gravity force, that is the weight, m into g, that is the gravity force. Then the next force, major force, which is acting on the fluid, is viscous force, which can be calculated from Newton's law of viscosity, mu a v by h. And there is another force that is called as turbulence force, which is due to mixing. When there is a mixing dominating in the flow, then there is a force developed that is called as turbulence force. So all are these major forces which are acting on the moving fluid. Now if all the forces are taken into consideration, in the analysis, we are getting the Reynolds equation. That is for turbulent flow. Analysis of turbulent flow is done by using the Reynolds equation. Now, if the turbulence force is not taken into consideration, if the turbulence force is ignored, only pressure force, gravity force and viscous force are taken into consideration, that is the equation obtained is called as Navier-Stokes equation. How many of you know Navier-Stokes equation? How many of you are comfortable with Navier-Stokes equation? For laminar flow, the analysis of laminar flow, how many of you remember the Navier-Stokes equation? For analysis of laminar flow, the equation obtained or the equation to be used is Navier-Stokes equation. And if the viscous force is not considered, then only pressure force and gravity forces are taken into consideration. Then we get the equation which is called as Euler equation. That is for non-viscous flow. Then the flow is non-viscous. So we start our analysis with the Euler equation for ideal flow, and then we move to the Navier-Stokes equation for laminar flow, and finally we enter into the Reynolds equation for analysis of turbulent flow. That is how the difficulty level of analysis keeps on increasing, isn't it? So today's session is all about the ideal flow. Let us talk about the Euler equation first. The Euler equation is obtained when we are taking these assumptions into consideration. The flow must be non-viscous. Non-viscous is also known as inviscid flow, or we can call it as frictionless flow, or we can call it as frictionless flow. Can you just let me know when the flow is non-viscous or frictionless? When tau is equal to 0, when there is no shear stress developed, then the flow. No, non-viscous is not ideal. Only non, by saying non-viscous does not mean ideal. Non-viscous means there is no shear stress developed between the adjacent fluid particles. There is no relative motion between the adjacent fluid particles. And the next assumption is steady flow. What is steady flow? When the fluid behavior does not change with time. When the pressure, density, velocity, they are independent of time. Then the flow becomes steady flow. So when we develop the mathematical expression keeping these assumptions into consideration, then we will get dP by rho plus G into dZ plus V into dV is equal to 0. This is called as Euler equation. And if we integrate this equation, then we will get integration of dP by rho plus G is constant, integration of dZ is Z plus integration of V dV is V square by 2 is equal to integration of 0 will be a constant parameter. These are Euler equation. One is the differential form of Euler equation. Another is the integration form of Euler equation. These are called as Euler equation. And for the Euler equation, the assumption to be taken into consideration is the flow must be non-viscous, inviscid or frictionless, as well as the flow must be steady flow. So we are just one step behind the Bernoulli equation. From this equation, we can easily obtain the Bernoulli equation when we taken into consideration another assumption, that is incompressible flow. Anybody is having any idea when do we call the flow to be incompressible? What is incompressible flow? Any idea? What is incompressible flow? When the density of the flow is neither be a function of space nor time. If density remains constant, then the flow is incompressible. In the previous expression, I have taken pressure inside the integration because the pressure was not constant, but here the pressure becomes, sorry, the density was not constant. Here the density was not constant. That is why we have not taken density outside, but as we assume the flow to be incompressible, then we are left with P by rho plus Gz plus V square by 2 is equal to constant. That is nothing but our favorite Bernoulli equation. This is called as Bernoulli equation. This is called as Bernoulli equation. And what are the assumptions for Bernoulli equation? There are three assumptions we have taken into consideration. So each and every term here represents the energy of the fluid. The first term represents the pressure energy of the fluid. The second term represents the potential energy of the fluid. And the third term represents the kinetic energy of the fluid. And the sum of all these three energy is nothing but the total hydraulic energy or mechanical energy of the fluid. It is called as hydraulic or mechanical. Why do we call it as mechanical energy? Because these energy can be easily converted into mechanical work. That is why they are known as mechanical energy of the fluid. They can be converted into mechanical work. So that is how we obtain the Bernoulli equation. Is this clear? So my question to everyone is, what is the unit of each and every term? What is the unit of each and every term here? Can you guys let me know what is the unit of each and every term? Actually, pressure energy is written as pressure into volume. That is the pressure energy. And M into G into Z is potential energy. And half mv square is kinetic energy, isn't it? Pressure energy is pressure into volume. if we divide each and every term by mass, so volume per unit mass is 1 by density. That is how P by rho is coming into picture. If we divide this by mass, that is how Gz is coming into picture. If we divide with mass, then V square by 2 is coming into picture. So it is energy. The unit of energy is joule. Pressure energy is joule. So the unit of each and every term is, it is energy per unit volume, sorry, per unit mass. It represents energy per unit mass. It represents energy per unit mass. So the unit is joule per kg. It is joule per kg. It is not joule per meter cube. The unit of each and every term is joule per kg. Is this clear? So when the flow is non-viscous, steady and incompressible, we call that flow to be ideal flow. We call the flow to be ideal flow, and for the ideal flow, the total hydraulic or mechanical energy of the fluid always remain constant. And that is why the Bernoulli equation is nothing but the energy conservation equation for an ideal flow. So I was asking about the difference between ideal flow and ideal fluid. For the fluid to be ideal, listen very carefully. That is how the questions can be asked in interviews. For the fluid to be ideal, the fluid properties are going to decide. For ideal fluid, the fluid viscosity must be 0. The fluid compressibility must be 0. The fluid surface tension must be 0. If these three properties are at 0, then the fluid is said to be ideal fluid. Viscosity 0, compressibility 0, and surface tension 0. And when do we call the flow to be ideal? The flow is ideal when the flow is non-viscous. There is a difference between non-viscous flow and non-viscous fluid. Non-viscous fluid means viscosity 0. Non-viscous flow means shear stress developed 0. There is a difference. Getting it or not? So, ideal flow implies that the flow must be non-viscous, as well as the flow must be steady, as well as the flow must be incompressible. The flow parameters are going to decide the nature of the flow, whether it is ideal or not, and the fluid properties are going to decide whether the fluid is ideal or not. I hope it is clear to everyone. So in Bernoulli equation, what we had written, P by rho plus Gz plus V square by 2 is equal to constant, and the unit of each and every term is joule per kg. Now this is one form of Bernoulli equation, one way of writing the Bernoulli equation. Other way of writing the Bernoulli equation is, if we multiply whole equation by rho, because rho is a constant parameter, so there is no effect on the right hand side. So we can also write it as P plus, it will become rho Gz plus the third term will become rho V square by 2 is equal to constant multiplied by rho is another constant. What is the unit of each and every term here? So again, first term represents the pressure of the fluid. That is called as static pressure of the fluid. First term represents the static pressure. What is the unit? Yes, the unit is Pascal. What is the unit in terms of energy? Still it represents the energy. The first term represents the static pressure of the fluid. The second term represents the hydrostatic pressure of the fluid, rho Gz, from the hydrostatic law. That is called as hydrostatic pressure. And the third term can be called as dynamic pressure of the fluid, which is having the unit of pressure, but it is the kinetic energy which is represented in the unit of pressure. That is called as dynamic pressure of the fluid. And when we combine the static pressure and hydrostatic pressure, when we combine the static pressure and hydrostatic pressure, we can call it as piezometric pressure. Have you heard the name piezometric pressure? The static pressure is obtained from the manometers. Manometers are the instrument used for measuring the static pressure of the fluid, P. So this is the reading of the manometer. Can you just let me know the static pressure? Will it be absolute pressure or the gauge pressure? In this equation, the static pressure, will it be absolute or gauge? Can you let me know? So pressure into volume is the pressure energy, but volume is missing here. So each and every term represents energy per unit volume here. The unit is joule per meter cube, or joule can be written as Newton meter. So it will be Newton per meter square. That is how Newton per meter square or Pascal can also be obtained. Joule per meter cube is nothing but Newton per meter square. So Joule is Newton into meter. So my question to everyone is, the static pressure, is it absolute pressure or the gauge pressure? Another way of writing, this is the second way of writing. If we divide the whole equation by, if we divide the entire equation by rho and g both, then we will be getting P by rho g plus it will be left with g, then v square by 2g is another constant. This is the expression we are frequently using in our mathematical calculations. This is the third way of representing the Bernoulli equation. What is the unit of each and every term here? What is the unit of each and every term? So Z, in Z, m into g is missing, so it is energy per unit weight. It is the energy per unit weight, that is joule per Newton, or we can call it as meter. So it is head, it is the static pressure head. First term represents the static pressure head. Sorry. What happened? Yes. The first term represents the static pressure of the fluid, static pressure head. The second term represents the potential energy head of the fluid, or we can call it as datum head or elevation head. It is also called as datum or elevation head. The third term can be called as the third term. We can call the third term to be kinetic energy head, or we can call it as dynamic pressure head, or we can call it as velocity head. So these are the three ways of representing the Bernoulli equation. This is number 1, this is number 2, this is number 3. But you should be clear with the unit of each and every term. The first expression represents energy per unit mass, the second expression represents energy per unit volume, and the third expression represents energy per unit weight. Is it clear to everyone? Is this clear? Yes. Now, good evening, Prabhas. Welcome. Welcome to the session. Now, let us move to our assumptions which are required in applying the Bernoulli equation. I've already discussed about some of these assumptions. Non-viscous flow, tau must be 0. Steady flow, pressure, density, velocity, they are independent of time, or we can say local acceleration should be 0. The flow must be incompressible. Density should not be a function of space nor time. Density must remain constant. There is no heat or work transfer. What does that mean? There should not be any other form of energy transfer. No other form of energy transfer to take place in the fluid flow. Energy transfer can be possible in two ways. You must have studied in thermodynamics. According to thermodynamics, the energy transfer can be possible in two ways, either in the form of heat transfer or the work transfer. So there should not be any other form of energy transfer. And if the points are lying along a streamline, even if it is rotational flow, for the rotational flow field, the points should be on the same streamline. So these are the various assumptions to be taken into consideration. I had asked you guys, P is, what is P? The equation is P by rho g plus Z plus V square by 2g must be constant. That is the Bernoulli equation. What is P here? P is the static pressure of the fluid, which can be measured by using the manometer by writing the pressure equation. The static pressure, is it gauge or the absolute? It is purely your choice. You can take it absolute or gauge. That is your choice. It will not affect the final result. You can take the pressure to be gauge pressure or absolute pressure. What is Z? Z is the vertical distance from a reference line. It is always the vertical distance from a reference. You can draw a horizontal line, which is the reference line, and the vertical distance of the point from the reference line is Z, and the V is the flow velocity. It is the flow velocity. That is how we can apply the Bernoulli equation when the flow fulfill all the mentioned assumption in the question. Hi Rakesh Singh, welcome. Yes, it can either be gauge or the absolute. Now there is a question on the screen. Can you just let me know the answer to the question? Can you see the question and can you just give it a try? There is a question on the screen. The statement 1 is the integration of differential form of Euler equation of motion yields to Bernoulli equation. Is the statement correct? Yes, statement is true. The Euler equation only give rise to Bernoulli equation. The statement 2 says Euler equation is based on the assumption of conservation of mass. Is the statement 2 correct? No, it is false. It is not based on conservation of mass. It is based on conservation of energy. Option C. Statement 1 is true, but statement 2 is false. The Euler equation is based on the assumption of conservation of, what should be the correct answer? The Euler equation is not based on the conservation of energy actually. The Euler equation, if you go to the derivation, you will understand that the Euler equation is based on the conservation of momentum. It is the momentum conservation of Newton's second law which give rise to the Euler equation. So Euler equation is based on conservation of momentum or Newton's second law. Yes, Susoban. Conservation of energy will not be the correct answer. It will be the conservation of momentum. The second question on your screen. The Bernoulli equation is applicable. The next question. What is the answer to the next one? Bernoulli equation is applicable to which of the following options are correct? If you go to the assumptions of Bernoulli equation, you will come to know the flow must be steady, the flow must be incompressible, the flow must be non-viscous. If you combine these together, we can call the flow to be ideal. So steady flow of ideal fluids along a stream tube. D will be the right answer. Yes, Mithun. D will be the correct option. So that is how the theoretical question can also be framed out of these concepts. And the theoretical questions are actually more dangerous than the numerical ones. So when the flow is ideal, there will not be any energy loss in the flow. That is how we can call the flow to be ideal. This is, let us say, point 1. This is, let us say, point 2. There is a fluid flowing and the flow is ideal. So for the ideal flow, the total hydraulic energy at any point 1 will be equal to, that is not called as Bernoulli equation, Susoban. We do not call it as Bernoulli equation. Energy conservation is universal law. We can apply energy conservation everywhere. But if we are using the word specifically Bernoulli equation, then it is only applicable when the flow is ideal, when there is no energy loss. Have you understood it? So when there is no energy loss, then only we call it as Bernoulli equation. So total energy at 1 will be equal to total energy at 2. Or we can write H1 is equal to H2. What is H? That is the total energy head. I should have mentioned it here. This is called as H. H is the total energy head. It is called as total energy head. Right? H1 will be equal to H2. Or we can say P1 by rho g. P1 is the static pressure here. It is already shown. P1 is the static pressure at point 1. P2 is the static pressure at point 2. Static pressure is obtained when the manometer is attached normal to the flow. So we can say P1 by rho g pressure head at 1 plus Z1. How to find out Z1? You draw a horizontal line and call it as reference line. And Z1 is the vertical height of point 1 from the reference line, and Z2 is the vertical height of point 2 from the reference line. P1 by rho g plus Z1, and V1 is the velocity of flow at point 1, V1 square by 2g is equal to pressure at 2 plus Z2 plus V2 square by 2g. That is how we can write the Bernoulli equation for ideal flow. And similarly, we can apply for real flow also. That is not Bernoulli equation, that is called as energy equation. That is called as energy equation. We do not call it as Bernoulli equation. It is not called as Bernoulli equation. When the equation, the energy conservation is applied to the real flow, either laminar or turbulent, in the flow direction there is energy loss. If the flow is from 1 to 2, there will be some energy loss in the flow direction due to friction between the fluid particles, because the flow is viscous. So we can say, because the flow is from 1 to 2, the total energy at 1 will be equal to total energy at 2 plus the energy loss from 1 to 2, because the flow is from 1 to 2. That is why the energy loss is from 1 to 2. Or we can say E1 will be greater than E2 because the flow is from 1 to 2. The total hydraulic energy at 1 is equal to total hydraulic energy at 2. Or we can say H1 is equal to H2 plus the loss from 1 to 2. The head loss from 1 to 2 in terms of head loss. This is how you can write the energy conservation. So P1 by rho g plus Z1 plus V1 square by 2g, that is H1. That is H1 is equal to P2 by rho g pressure head plus Z2 plus V2 square by 2g, that is H2 plus HL. HL is the frictional head loss from 1 to 2. That is called as energy head loss or the frictional head loss. We can call it as energy head loss. And that is due to friction. That is why we can call it as frictional head loss also. If the flow would have been from 2 to 1, can you write the energy equation for the flow from 2 to 1? If the flow is from 2 to 1, if the flow is from 2 to 1, if the flow is from 2 to 1, then we will say E2 is greater than E1, or we can say H2 is equal to H1 plus HL from 2 to 1. That is how the energy conservation. So it will be P2 by rho g plus Z2 plus V2 square by 2g is equal to P1 by rho g plus Z1 plus V1 square by 2g plus HL from 2 to 1. So what we can conclude from here, the fluid always flow in the direction of decreasing total energy of the fluid. If the flow is from 1 to 2, that energy at 2 will be less than energy at 1. If the flow is from 2 to 1, the energy at 2 will be greater than energy at 1. So the fluid always flow in the direction of decreasing energy, or we can say in flow direction total energy decreases. In the flow direction, the total hydraulic energy always decreases. Is this clear? That is how we can extend the energy conservation equation for the real flow. If the losses are considered, the same equation can be called as Bernoulli equation. Otherwise, we do not call it as Bernoulli equation. Again, let us solve some questions and then we will stop our session. There is a question on the screen. Can you find out the answer to this one? Now it is your turn. Can you just solve the question which is there on the screen? There are two locations, 1 and 2. Thank you, Deepak. Thank you for your motivational saying. we are also human, and we also require motivation. And we get our motivation, we get our energy, we get charged up from the students' comments only. Definitely, I will bring more and more such sessions. Now there is a question on the screen. Can you just let me know the answer? Can you? There are two sections, 1 and 2. Horizontal pipe. The pipe is horizontal. Can we say Z1 is equal to Z2? Because the points are lying at the same elevation. The fluid pressure head is 32 centimeter. What is that? At the location 1. So P1 by rho g is 32 centimeter. It is P1 by rho g head. It is about head. And the velocity head V1 square by 2g is equal to 4 centimeter. The reduction in area at location 2 is such that the pressure head drops down to 0. What does that mean? The pressure P2 by rho g becomes 0 and the ratio of velocity at location 2 to that at location 1 is. The question is asking you to find out the ratio of V2 by V1. What is the answer? So if we apply the Bernoulli equation, we can say P1 by rho g plus V1 square by 2g should be equal to V2 square by 2g. Do you agree or not? Because I have put Z1 is equal to Z2 and P2 is equal to 0. That is what I have applied. So P1 by rho g is 32 plus 4, that is V2 square by 2g. V2 square by 2g is equal to 36 centimeter. So V2 square by 2g divided by V1 square by 2g is equal to 36 divided by 4. That is 9. But the question 2g getting cancelled out. But the question is not about V2 square by V1 square. It is about V2 by V1. Isn't it under root 9? That is 3. Isn't it 3? C is the correct answer. Yes, Bhavya. Where are others? Not interested in solving? Don't brought your notebook? Not carrying your notebook? C will be the right answer. Okay, those who have not given me the answer for this question, please, it is my humble request, give me the answer for the next one. The next question on the screen. The liquid flows downward through a tapered vertical portion of a pipe. At the entrance, this is the entrance. This is the entrance, this is the exit. Because the flow is from entrance to exit, that is the flow direction. The static pressures are equal. What does that mean? If we call the entrance to be 1 and exit to be 2, so P1 is equal to P2. Static pressures are equal. P1 is equal to P2. Isn't it? If for a vertical height h, the velocity becomes 4 times. V1 is equal to V and V2 becomes 4V. Then the ratio of h to the velocity head. What is the velocity head? So the question is about h upon v, velocity head at entrance. So V1 square by 2g. That is what we need to find out. The ratio of h upon V1 square by 2g. It is not velocity, it is the velocity head at entrance. So now if we apply the Bernoulli equation, for that we need Z1 and Z2. If I call this to be reference line, we can call any horizontal line to be reference line. If we call this horizontal line to be reference line, do you agree Z1 will be equal to 0? And point 2 is lying below the reference line. Do you agree Z2 is equal to minus h? That is important. If the point lies on the reference line, the potential energy will be 0. If the point lying below the reference line, the potential energy will be negative. If the point lying above the reference line, then it will be a positive value. So P1 and P2 are equal if I write the Bernoulli equation. So we can say Z1 is also 0. V1 square by 2g is on the left hand side is equal to Z2 plus V2 square by 2g. Put the value. V1 square by 2g is, if we put the values, V1 square by 2g. What is V1? That is V square by 2g is equal to minus h plus V2 is 4V square by 2g. Do the calculation. So it will be h is equal to 16v square by 2g minus v square by 2g. That will give you, so h will be equal to 15v square by 2g, and don't you think h upon v square by 2g is nothing but 15? Who is the correct answer? C is the correct. Mithun 16 कैसे आ गया? C will be the correct answer. 15 is the right answer. That is how you should be able to apply the Bernoulli equation. I hope it is clear. Any doubt to anyone, do let me know. Can you solve the next one? Can you solve the next question? The next question. A smooth pipe of diameter 200 mm carries water. It means the diameter is constant. Diameter is constant. And if the diameter is constant from the Bernoulli equation, velocity must also be constant. Sorry, not Bernoulli equation. From the continuity equation, velocity will also be constant. Continuity equation. Velocity will be constant. The pressure in the pipe at section S1, which is having an elevation of 10 meter, is 50 kilopascal. Pressure is given at 1. At section S2, elevation, the vertical height from the reference is given as 12 meter. The pressure is 20 kilopascal and the velocity is 2 meter per second. That is the constant velocity. Which of the following is true? The statement A and B are saying the flow is from S1 to S2, and the statement B is saying flow is from S2 to S1. The head loss is also mentioned. C and D are having the same head loss, but the flow is from 1 to 2 or from 2 to 1. So what we need to do is, we need to assume the flow from S1 to S2. You can assume from S2 to S1 also. We can assume the flow from S1 to S2 or S2 to S1. So what we can say, then E1 will be greater than E2 if we assume the flow from 1 to 2. E1, or we can say H1 is equal to H2 plus HL. If we are getting HL positive, then our assumption is correct. If we are getting HL negative, then our assumption is incorrect. The actual direction will be opposite. So by checking the sign of HL, we will come to know whether our assumption is correct or not. The magnitude will remain constant. It is only about the sign. It is only about the sign. So if we assume the flow from 1 to 2, and if we apply the energy conservation equation, so we can say P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g plus HL. We can say V1 and V2 are getting cancelled out. Z1 is 10, so it will be 50 kilopascal, 50 into 10 to the power 3 upon G can be taken around 10. So rho is 10 to the power 3 into 10. It is water. The fluid is water. Plus Z1 is 10 meter is equal to P2 is 20 into 10 to the power 3 Pascal. You should take care of the unit. And rho is 10 to the power 3 into 10 plus Z2. Z2 is around, what is Z2? Z2 is 12 plus HL. What we can say, 10 to the power 10 to the power getting cancelled out, it will be 5, 10 to the power, it will be 2. So we can say 15 minus 12. So HL will be around 2. What is that? What is the problem? If we take 9.81, then what? 10 and then 12. 15 minus 14. Yes. 15 minus 14. That is around 1 meter, and it is having a positive value. It is around 1. Because I have taken, that is how you can keep your calculation simple. Because there are only two options for HL. One is 0.53 and another is 1.06. They are having a huge difference between them. So even if you take even if you take G as 9.81 or 10, then your answer will not be getting affected much. So it is almost 1 meter and the flow is definitely from 1 to 2. So option C is the right answer. Yes, but it is MCQ question, na Bhavya? Then it will not create for NAT type question. If the question is numerical answer type, then definitely you need to take 9.81 only. But here, that is why I am not getting the exact answer. But yes, I can find it out. It is not going to be 0.53 at all. It is close to 1 meter. That is how you can keep your analysis simple. Can you solve this question? This is your assignment question. This is your assignment question. And I will give you the answer to this assignment question in my Telegram group. If you have not joined me on the Telegram yet, do join me on the Telegram, Mechanical by Chandra Sir. This is one of the assignment question, and there is another assignment question, that is assignment number 2. Please do solve these questions, and I will share the PDF also for this session on our Telegram group. So be part of my Telegram group, and I will keep on giving you the questions every now and then. So it is going to be very, very helpful for all of you. With this note, let me take your leave, and do not forget to join me for the Menti quiz, the last session of fluid mechanics, that is on Friday at 8 p.m. Friday at 8 p.m. I will be live for the Menti quiz, and the syllabus is whatever we have discussed in all the sessions so far will be the syllabus of the Menti quiz. All right. There is a possibility that the question can come out of the syllabus also. Means it will not be out of the fluid mechanics syllabus, but the question can appear from the topic which I have not discussed. So as I said, the person who had never committed mistake had never tried anything new. So if you have never failed, then it means you will never succeed. So failure is the part of the success, or committing mistake is definitely the part of your journey towards success. So don't be afraid of committing mistake. Don't be afraid of failure. Keep on preparing hard in the right direction. Definitely success will be all yours. With this motivational note, let me take your leave. Thank you. Enjoy. Have a good night. Stay safe. Stay healthy. And keep preparing with the BYJU'S exam prep. Thank you guys. Thank you very much. And Jai Hind.